Good morning. Should be Friday, April 3rd as you complete this lesson. Let's see, if you haven't already watched 10.6a, Identifying Quadrilaterals, that's our lesson for today. Why don't you go ahead and pause the video and complete that before continuing. Otherwise, if you're still with me, I assume you've already done that. Please don't upload that. We'll upload it together with our practice work today. Along with the video today, we're going to do a review. We're going to do some sketching and defining of these quadrilaterals, and then some practice. I'll also offer a G67 challenge. So our practice sheet will look like this. You can put your review up top. We're going to do some sketches, and then we'll have two activities to do. One of the two, you'll choose one of these two activities here. All right, let's go ahead and get going with review. Go ahead and pause the video. Take about 5 minutes to complete this. And this is multiplying without a calculator down here. Go ahead. All right, let's go over the answers to the review. This would be an obtuse triangle because this is a 92 angle. If you take 180 minus 55 minus 33. So identifying all angles here, this is going to be 90 degrees, so the vertical angle will be 90 degrees. And then if this one is 125, this one here has to be 55. So 125, 55. And of course, because these are parallel lines here, and this is a line that intersects two parallel lines, these two angles down here will also be 125 and then 55 degree angles. The complement angle here, well, 90 minus 40 would give you 50 degrees, and 180 minus this 45 degree angle here would be 135 degrees. When you multiply these out, don't forget to carry the 0. You would have 41.4. You got two decimals, so you take the decimals out and then just put them back in at the end if you forgot how to do that. So there's a quick reminder. This is not an approximate answer, that's an exact answer. Down here, this is an obtuse scalene triangle. You can see the obtuse angle here, and you're just not sure if it's scalene or not. But remember, U, T, and S, these here are designations, and they're all different. And so that means that these sides are all different. And so instead of using hash marks or actual measurements, sometimes they'll use 3 different letters. So this is definitely a scalene triangle with 3 different sides, and there's your obtuse angle. These two here, this is going to be an isosceles triangle because it has 2 angles that are the same, or 2 sides that are the same, and of course this is a right isosceles triangle, and this is just an acute isosceles. You can see the 2 sides that are the same, and here's your acute angles there. All right. For the lesson, Identifying Quadrilaterals, I think that most of you know just a ton about quadrilaterals, but when you've got all 7 together and you actually have to lay out and define and do some matching with definition to shape, it becomes a little harder. And so that's what we're going to work on today, and I'd like you to be patient with me because I think you probably know less than you think you do. So a couple of things to remember, that these little arrows here will sometimes be used to represent the fact that these are parallel lines. So here you can see that these two are parallel because there's 2 little arrows, and then over here these 2 are parallel. There's 1. There's also the symbol for congruent. 1 little tick mark and 1 tick mark show that these 2 are congruent or the same length, and then 2 tick marks and 2 tick marks, these 2 are also congruent. And then the symbol for congruent angles will be the same. This has 1 little line going through the angle, 1 little arc, and this has 1 little arc, so these 2 angles are the same, and these have double arcs. So this with a double arc and this with a double arc are the same. Let's get right to work sketching some of these and see how you can do defining them. Take and draw a quick little picture of a trapezoid, and then why don't you see if you can define a trapezoid, and then do the same thing for a parallelogram, a rectangle, a rhombus, and a square. If you're not sure, get the sketches down and I'll help you with the definitions of them. We'll just do these 5 first, and then we'll add in the other 2. All right. Definition we're going to work with for a trapezoid is 1 pair of parallel sides. So it's a quadrilateral, 1 pair of parallel sides. These are all quadrilaterals. This one here, you could say it's a quad where the opposite sides are parallel. So this side and this side are parallel. They're opposite, and this side are parallel. It says that the opposite sides are parallel and congruent, because these opposite sides are also the same length. So opposite and congruent. Opposite sides parallel and opposite sides congruent. All right. Well, a rectangle, if that's the definition of a parallelogram, a rectangle can be given the definition of a parallelogram, opposite sides parallel and congruent, a parallelogram with 4 right angles. Okay, see how that worked out? We're using the definition of a parallelogram for a rectangle because it is a parallelogram, but it has 4 right angles. A rhombus, well, again, we're going to use that definition for a parallelogram, opposite sides equal and congruent. So it's just a parallelogram with 4 congruent sides. So notice, angles are not congruent, but the sides each have 1 little tick mark. So a rhombus is a parallelogram with congruent sides. All right, and a square is a parallelogram with 4 right angles and 4 congruent sides. So what's the most important definition? I think the parallelogram, because everything is based off of a parallelogram. This is a parallelogram with 4 right angles. This is a parallelogram with congruent sides. This is a parallelogram with congruent sides and 4 right angles. See what I'm saying? Okay. Yes, one of your quizzes you'll be expected to identify them. Tomorrow, one of them you'll be matching definitions at some point. All right, so go ahead and draw a quadrilateral and a kite and see if you can come up with a definition for those. All right, here's the definition for a quadrilateral. It's just no congruent sides, angles, no parallel lines. It's just 4 random sides put together into a shape. A kite is a quadrilateral that has 2 sets of adjacent congruent sides. Get that space in there. So these sides here are congruent. They're the same size, and they're adjacent. They're joined together at one of the vertices. And same here. These 2 sides are congruent, the same, and they're joined here with they're joined at this vertex here. The other cool thing about kites is when you bisect the sides or the vertices, it forms a right angle. So kite, 2 sets of adjacent sides. You got that down? All right. Now you can take a choice of one of the 2 practice activities. First of all, you can go through and we can name these shapes, and I'll make them a little bit bigger so you can see them a little bit better. This is activity choice number 1. Activity choice number 2 would be to answer these 4 questions after you do a little experiment where you take some straws or some strips of paper or something else. You cut them so you have 2 3-inch pieces and 2 4-inch or more pieces. They need to be different lengths. So if you're going to go ahead and do the standard activity, let me make this a little bit bigger. And go ahead and identify shape number 1 and 2. You can work your way all the way through 14. All you're doing is just telling me what the shape is. And yes, you can use abbreviations. Go ahead, pause, and make sure you do all 14. Okay, here are the answers. Rectangle, quad, parallelogram. This here is a trapezoid. This one here looks like it might be stretched out a little bit, but it has 4 tick marks, so that's a square. This is a rhombus. You can see that 1 little tick mark shows that these are all the same. Parallelogram, rectangle, square. This is just a quadrilateral. There's nothing. Oh, let me take a look at that. That is not a quadrilateral. That is a trapezoid. It has 1 set of parallel lines right here. Okay, so let's see. This here is a kite. You can see the adjacent sides here are the same. We have a rhombus, another trapezoid, and a parallelogram. Okay. If you are going to do the G67 challenge activity, go ahead and take a few minutes and try to make these straws and follow these directions and see how you do. get my face out of the way here. Okay. Here are the answers to that activity. Well, trying to create all 7 quads, can you make all the shapes with just one set? Why or why not? Well, you could make a rectangle, you can make a parallelogram, you can make a kite. What do you observe about the sides and the angles? Well, with the parallelogram, the opposite sides here, they're going to be congruent and parallel. The angles on the right, the opposite angles are all going to be equal. They all add up to be 360 degrees. There's an observation you can make about any quadrilateral. And the same thing here. These angles here, when they bisect, this is going to make a 90-degree angle. So some of the observations you can make. This next set, now if you work with a second set that's just like the first, can you now make all the shapes? Why or why not? Well, you can certainly make a trapezoid. So what I used here is I used the blue for a symbol for the second set. So if you take and do a long one and then 3 short ones, you can make a trapezoid. If you use 2 blue short ones and 2 red short ones, or 2 long blue ones and 2 long red ones, you can make a rhombus. Over here you can make a square if you use 4 short or 4 long too. That's just like the rhombus. The question is can you make a quadrilateral? Well, some people thought, well, if I do this, that would be just a quadrilateral. This would be 2 sides the same length here, and then 2 sides the same length here. Obviously these would be the long ones and these would be the short ones. But that's not really a quadrilateral. By definition, that is a kite, because it has the opposite sides here are adjacent and congruent. This is called a concave kite, which we also call a dart. So technically this isn't quadrilateral. This is one of those activities that I wish we could be present in class to go through and see if you can make a quadrilateral. I think the answer is no, because you need 3 different or 4 different lengths to do that, and we only have 2 different lengths really, because these shapes here are these blue straws and the red straws are really all the same. So you need different length sides to produce different length angles. And the reason why I'd like to do it in class is because that if you overlap the straws and the way you put them together, or the pieces of paper, yes, you can create them, but we have our limitations with what we're working with. So this one here is one I'd like to explore in class a little bit further with you later on. All right, that's it for today. You can go back up here. Let me see. Please lay down your review and your sketches and either of these 2 activities, whichever one you chose to do, next to your video, and upload it to 10.6a quadrilaterals. That's it. Have a great day. I will see you tomorrow. Tomorrow we'll take the quiz on 10.6a, and we'll do an activity with it as well, some review. Okay, thanks.